So I'd like to thank Daniel and the ITF Center for Data Innovation for inviting me to talk today about Google Translate and data innovation. It's a fun story I love to tell. I'm going to be talking first very briefly about the history of machine translation so we can place where Google fits into it and why and how Google got into the translation business. I'm going to go over a little bit about what Google Translate is, since I can't assume you all know, and we'll look at what kind of impact it's having in the world. And then, for those of you who like technical stuff, we'll get the fun part, charts and graphs, how the data really fuels the translation and the quality. So first, a very quick summary of the history of machine translation, just a few high points and low points. To point out that this is one of the first things people tried to do with computers, is translate one language into another. And there were some very early successes people were excited about, which was what's called rule-based translation, where the grammar of one language is encoded directly in the algorithms of software and it directly converts into another language. And there were some early results that got people excited, as we see, with 6 whole rules and 250 words. Some promising results, but that gave way quickly to disappointment in the 1960s. Somewhat famous or notorious federal government report said machine translation's not working, it won't, we shouldn't invest in it. In that white space, I don't want to imply nothing happened, but there was a lot of work in industry on rule-based translation, and some important things were done for custom applications, but a really big general purpose translation system didn't happen for a long time. The major research that broke through to a completely different approach was IBM, starting in the late 80s and published in '94. What they called example-based translation. So just take a whole lot of good translations humans have done and train a program to learn from those examples and generate new translations, and it worked pretty well. So on my timeline there, I have just a little bit after that Google was founded. So what do those things have to do with each other? At that point, Google was started to crawl the World Wide Web, harvest web pages, and build an index to search it. Well, this idea of example-based translation and Google's crawling the web led to Google Translate, and we'll talk about how that worked in a bit. But first, why Google cared. Google started as an engine to search the World Wide Web, but quickly broadened its mission to be defined as make the world's information universally accessible and useful. So we want everybody in the world to be able to get at any information the world's got that they should be able to have. And a search engine helped a lot, but an even bigger problem than search is language. Most of the world can't read most of that information that's on the web. Half of it's in English, most of the rest is in a handful of other languages, and there are hundreds of millions, maybe billions of people who can read hardly anything of what's on the web. So if we want the world to be able to access all that information, we've got to solve the translation and language problem. So the web page on the left, I'm guessing to most of you looks like an impenetrable wall of squiggles. Being in Washington, maybe some of you speak Thai, but that's what the World Wide Web looks to most people in the world. So a lot of people don't know that Google's #1 use of Translate by quantity of translation is directly in a browser. This is the Chrome browser. Someone's looking at a web page, they can't read the language, get a one button, click, translate, and you get a web page translated to your own language. So that's about 60% of the translation bytes we do every day. Our next biggest is our web application. People come here every day to assist with translation. Sometimes they know the language they're translating to or from a little bit. They need a little bit of help and enter text. And this has the more feature-rich application with speech and transliteration and so forth. Our fastest growing by far is mobile translation. These are Android and iOS translate applications. Much of the developing world is coming online first on mobile devices, so this is becoming increasingly important. It's also emphasizing for us the importance of speech, because in a lot of languages it's very, very hard to type on a phone. Even in English it is, but in most languages it's harder. So what impact is Google Translate having on the world? Well, it's big, first of all. We're up to 80 languages now, so we can cover a lot of people. About 200 million monthly active users. Among Google products, it's the one that's most used outside the United States, hitting a lot of parts of the world that a lot of web services are not. As I mentioned, the mobile applications are growing really fast, 100 million and doubling year over year. And we're doing over 1 billion translations a day. Now, translation has a lot of industrial applications, and we see Google Translate used for some of these things. News organizations scanning press releases and reports from other countries and other languages. Businesses looking at their customer feedback. But a lot of what gets us excited and keeps us motivated is the little and more personal stories that rarely make the news, but occasionally they do, and we see stories like this, where you've got a person who doesn't speak the local language, needs medical assistance, and first responders are able to provide the assistance using a mobile app. In this case, police had a phone with them that had Translate on it. Something I've been learning more about that's a painful subject, but happy to hear we can help a little. Talked to the National Domestic Violence people yesterday, and it turns out a lot of victims of domestic violence are in cultures where they aren't comfortable getting help. Often language is a barrier. And people are beginning to discover this, and more people need to know this. In this case, even in a small town in Texas, the police had tablets with them that had a Translate application with them and were able to help a victim get prompt assistance. So this is making an impact all over the world. And sometimes it surprises me. This is a slide I did after we launched 9 new languages in December. And these are languages I hadn't even heard of a couple years ago, most of them. And I just took a look at where they're being used, and surprised to see how far-flung the use of these relatively unknown languages is. These are languages that are mostly spoken in Central Africa and Southeast Asia, but they're being used all over the world. I dug a little deeper. Right now, of those 9 languages, the most used is the Somali language. And we didn't expect a lot of use of Somali, because Somali is not a very internet-connected country, but it turns out Somali is the number 9 of the top 10 countries where the Somali language is used. Actually, most of the translation to and from Somali is happening up in northwestern Europe, Norway, Sweden, Denmark, where there's a lot of Somali immigrants, which I didn't know. And looking at these previous slides of what happens with first responders and people in need of help, I can only imagine what a Somali migrant in Sweden needs help with, and I'm hoping we're making a difference there too. So I promised you some technical detail. So how does this all work? What does it have to do with innovating with data? Well, as I mentioned, Google started out its life crawling the World Wide Web, making copies of web pages and scanning them in order to build an index for searching. Now, the vast majority of those pages, especially at that time, were in English, but we found pages that were in other languages. For search, that might at first have been largely a nuisance. There's things that nobody could read and understand. So over on the right is a page we found in a language I don't know. Nobody on my team knows it, but fortunately we're able to identify it as the Lao language. So there's not very many of these pages, and we don't understand the language personally, but we can find some things in it, like this particular one has Tony Blair in the middle of it. And we also found another page in English on the left. It's a news story, has Tony Blair in exactly the same place. And if you browse through the page, even on the Lao text, you can find a few things that make it look similar. You find that date 2006 above it. Blair's name occurs 1 or 2 other times. There's some other patterns. The pages are about the same length. So you can guess that these pages are actually translations of each other. Now, there's not very much Lao on the web as a percentage of the total World Wide Web. Very, very small, but the web is really, really big now. So out of the hundreds of trillions of words of text that are on the World Wide Web, we're able to find actually 11 billion words of Lao. Tiny percentage, but it's a big quantity. Then when we go through and scan for web pages that could be translations, can we find pairs like on the previous slide of an English-Lao translation? We find about 20 million words of Lao-English translation. Now, you may remember my first slide where I pointed out that first IBM experiment in 1994 got good results from about 2 million sentences of English-French. So we've got about the same size as that experiment in English-Lao. So from all these pages, we can run a training pipeline. And this is a simplified version of what we do. But we start with the entire World Wide Web. We crawl almost all of it, everything we think might be worth indexing. This is trillions of pages, hundreds of trillions of words. On the top, there's that parallel data mining process. It finds as many as we can of those pairs of web pages that look like translations and build this database of parallel translations. On the bottom, we're doing what's called a language model. So for example, for Lao, we just go through and find out what are the common strings of characters, common words, common phrases, and build up a model of what looks like a good sentence in that language. So we get a language model, then a machine learning process, and that upper right builds the translation model. So here's a simple walkthrough of how this is actually applied when you go to Google Translate and type in a sentence. So at the top, a user has typed in "the cat sat on the mat" and is looking for a translation into Spanish. So the translation engine starts from the left, looks at the first word, the, says, okay, well, when we see the in English, what words did we tend to see in Spanish web pages that look like translations? And the answers are el and la, not surprisingly. Well, let's try, we did pretty well in one word, so let's try 2 words, el gato. The cat. When an English sentence starts with the cat, what do we tend to see in Spanish? Well, we see a few things at the start, most often el gato. Sometimes we see, very frequently, el gato se. Also occasionally see la gato or a lowercase el gato. Now, those of you who know Spanish will recognize we don't really have a translation on the second one. The se is a verb particle. So this illustrates, at this point, we still don't understand the grammar of what we're doing. We don't understand the meaning. We don't know this is cat or what's going on. All we know is that that se often occurs in that place. So when we worked out okay on 2 words, we try 3, the cat sat, we don't find anything. So then we move on, we try cat sat on. I'm skipping a lot of the details there, but cat sat is a good one. It finds a very strong match in the Spanish to gato se sentó. That's the only really good match it finds. Go out towards the end. Amazingly, we actually find a lot of English sentences that end with the words on the mat, and it translates in all kinds of different ways to Spanish, and those are some examples. So from these, we stitch them together. That el gato se stitches nicely with gato se sentó, and we come up with a few candidate sentences, mostly different variations of on the mat, and we consult the language model that we built and say what looks like good Spanish, and come up with a best sentence, el gato se sentó en la estera. In this case, that's pretty good. That process takes almost always under 50 milliseconds. So this is back on the user's desktop in about the time it takes to press the key. So a lot of people ask, how well does this work? That example worked fine. Does it always work? Well, sometimes it works really well. Our best translation pair, one of the top few, is Spanish to English. So here's a Spanish Wikipedia article I took from a couple of weeks ago when Nelson Mandela was in the news. I picked a paragraph from there, took our engine to translate it to English, and we get, after being imprisoned for over 27 years, serving a life sentence, Nelson Mandela was released, received the Nobel Peace Prize, and was democratically elected as president of his country. That one came out perfect. Before being imprisoned, had been the leader of Umkhonto we Sizwe and so forth. Well, we dropped the word he. That's because Spanish allows you to leave out the subject of a verb a lot more often than English does. There was no L in there, and we lost it. If you go on reading, I think you'll find this is pretty readable. It reads, and this is typical of that page when it's translated by Google Translate into English. It reads like a human did it, but maybe was a little careless, made a few mistakes. So that's us at our best. Now, to be honest, it's not always that good. So let's try Chinese. I went and looked for a corresponding paragraph in Chinese Wikipedia at the same time. Before becoming president, Mandela was an active anti-apartheid party, either the ANC armed organization, Spear Nation Leaders. Okay, I won't read the rest out loud. So it doesn't always work perfectly. In this case, you can probably get the gist of what this is about. If you don't know Chinese, the bottom is a huge improvement over what's at the top. So you can get the gist of it. You can probably get some relevant facts. You'd be advised to be careful about checking whether any of them is accurate, and it would probably be painful to read it for a long time. But again, getting back to some of the situations, there are use cases like these first responder emergency situations where just finding out what's going on with somebody, is this a medical emergency or a legal emergency or what, can make a lot of difference. So those are a couple of examples. So what determines why some languages translate better than others? Well, the reason we're here is data, and if there's one thing I want everybody to take away, it's overwhelmingly this is about data. It's how much data we can find, mostly from the World Wide Web or any other source. Huge quantities of data make this possible, lots of examples to learn from. If you can just imagine how many web pages you have to look to find all those translations of on the map, just from things people happen to have translated, it's a lot. But then that gets limited by the next step up, which is the particular language you're trying to translate. A big reason Chinese translates so much less well than Spanish is just a lot more different from English in its syntax. And so once those two things have determined how good your translation is, then the cleverness of engineers kick in. That's when the people on my team roll up their sleeves and try to get clever. So on top of the algorithm I'm showing here, there are a lot of extra tricks going on, but this much is from data, this much is from the language, and we can just do a little more so far by being clever and introducing knowledge of language. So an illustration of how important data is and what kind of quantities you need to get good quality. This is a graph of quality of language and how it improves with increasing amounts of data. So we're starting at the left with 10 million words of translation. We're working up through 1 billion in the middle and 100 billion on the right. And this is French, German, and Spanish, and how their quality, according to an automated measurement, improves as you get more data. We did this by deliberately throwing away some of the data we've got and retraining just as an experiment. So as you can see, you go up really, really steeply from 10 million through 100 million, leveling off a little bit at 1 billion, but we're continuing to improve even past 100 billion words. The more examples we get, the better it gets. On the other hand, illustrating the issue about language complexity I mentioned on the previous slide, German just looks like it's never going to catch up to French and Spanish on this algorithm. Its word ordering is more complicated, it changes a lot more, its word forms change a lot more, as I remember from high school memorizing adjective endings. They're just complicated. So this is another way of illustrating the point with more languages. Each blue dot here is a different language, and the dot represents on the vertical axis the quality we get when translating from English into that language. On the x-axis, again, we're getting increasing data on a log scale. So this shows that data drives quality to a large extent. The line shows roughly the trend of more data means more quality. On the other hand, it also illustrates how some languages don't do as well. Those ones I've circled in red are mostly ones where word forms change a lot. Finnish, Estonian, Hungarian, Turkish, Russian. We just can't get enough examples to cover all the ways that words change. We're working on ideas to solve that problem, but it's still hard. And then this illustrates the same issue going to English. Again, more data means higher quality. The dots are mostly higher because we do a better job going into English, mostly because that language model being better. But again, languages that are very different from English don't do as well. This is a different group of languages this time. It includes Chinese, Japanese, Korean. So it's languages with very different word order, languages that can omit things that are required in English and things like that. So that quickly is how lots of data drives Google Translate. We have a lot more to do to keep making it better. We always want more data. We're also looking hard at the quality of data. We've kind of trapped ourselves in a vicious circle where when we get too good, a lot of people who are translating their own websites and content on the web just use our engine or a competitor's engine. There are other people doing the same thing from roughly the same type of data, and they just post those. And if we crawl those and train our engine on our own translations, it doesn't actually make things very much better. So we're looking at filtering out that and other low quality content. But another thing we are looking harder at that could help a lot, especially for small languages and some important use cases, is just asking volunteers to go to our website and give us translation help. I mentioned we launched the Maori language. That was on my list of new languages. That has a very small speaking community in New Zealand and Australia. We could not find very much data on the web. We couldn't find very many people, even for pretty good money, to help us with the translation. But when we just asked people, would they volunteer to spend a few minutes either translating things or rating translations for us, it worked really well. And we could not have launched the Maori language without the help of that volunteer community. So we'll be doing more of that to help us get something going with small languages, to improve some of those smaller languages. We're also experimenting with how we can solve problems of people wanting to translate things that we don't often find on the web. On the web, we find a lot of very professional content translated. We find government documents, we find patents, we find technical support documents. It doesn't help a lot when people go into translate and just want to say, LOL, I love you, happy birthday, which is, or talk gossip about a celebrity. So asking people to quickly give us feedback on new things that are showing up in translation is a promising area of how we can get better translation. We've also looked at other sources on the web that are freely available. We published a paper last year on how we might be able to use Wiktionary to solve some of those problems with highly inflected languages that I mentioned. And a final big area is speech. More and more people are using speech translation. Again, as I mentioned, the mobile application is becoming more and more important. Its usage is doubling year over year. It's very big in the developing world. A lot of people need that in order to enter data on their phones. So we're looking at how people speak when they're trying to get things translated. It's often different from what they type. So we're collecting data about speech. So things I hope you will take away from this talk: the power of very large data. These numbers are just mind-boggling, even for those of us who worked at Google a while, the hundreds of trillions of words. But they can do things you just couldn't even begin to imagine 50 years ago when the amounts of data people could work with were so much smaller. Another is the things that can happen when you repurpose data. Nobody working at Google in late 90s, early 2000s had any idea that all this web crawling they were doing and all the tools for analyzing web pages would be used for translation. It took about 5 or 6 years for that idea to click and for the work to begin, and it produced something that is actually arguably giving even more people access to information on the web than the search engine is. And that we have a lot more to do. With more types of data and more of it, we hope to be able to do more to help the world and change lives. So Once again, I love talking about Google Translate, so thank you for giving me the opportunity. This is thank you in the 15 new languages for 2013. And I look forward to taking your questions. Yes?
So in your example of the cat, that Dalgazo could be used as the animal or as a nickname, let's say, drug or something.
Yeah.
So how are you using underlying tools like text analytics tools to help improve your machine translation in the context right?
Very good question. The question is, one word can mean something completely very different in different contexts, and it can be embarrassing and painful when you get the wrong one. And do we use text analytics to look more broadly in the text to figure out what the context is? The answer is right now we do not. We just translate sentence by sentence. Very often there are clues in the sentence itself that says what kind of thing you're doing, but I'm definitely interested in long term if people translating a larger document and not just a sentence to kind of scan the document and get some idea of what the key concepts are, but we're not doing that yet. Yes?
How much is Google Voice a source of machine learning or information from Google Translate?
By voice, you mean the speech recognition, the voice engine? Yes.
Acquisition of Grand Central and then.
Okay, so Google Voice, the product that came from the acquisition of Grand Central, is a tool for managing phone numbers and voicemail, and it makes use of speech recognition to transcribe voicemail. There is a team that works on voice recognition generally for a lot of purposes, for that, for search, for dictation, and so forth. So that team is always collecting data about speech to do a better job of recognition. Right now, they're not doing much specifically on the translation target of speech recognition, but I anticipate that will become more important in the future. Yeah.
So one of the challenges of the scientific community is how do we encode meaning in language? And do you think that's elusive? Are we making any progress there with semantic analytics?
Great questions. The question is about the problem of meaning and do we understand the meaning? Right now, like I said, the translation engine really can't be said to understand the meaning of what it's translating at all. But there is some research that's been done. Tomas Mikolov at Google has published some papers on neural network techniques for building up a model of meaning where you run over large amounts of text and look at what words relate to one another, modeling the meaning as a high-dimensional vector, so a sequence of hundreds of numbers. And there has been some research and some going on in my team on how this could be used in translation and how it could be used multilingually. So he's discovered some interesting things, like you come up with this vector to model all these different words, or a vector per word, do it in, say, English and German, and you find some interesting parallels. Like the relation between dog and cat might be mathematically the same as between Hund and Katze in German. So there is some research that points that way, and that might be able to look at the meaning of a word, but it's still just research. We're not using it in applications yet. Great. Yes.
The data you showed about where it's being used, is that publicly accessible in any way? Like Google Trends is for searching?
No, we don't generally make that available. I published that for this slide. It's on the website. But I didn't put any numbers on it either. But we'll be looking at what data we can release about this. Yes.
Does model use any language triangulation?
I'm sorry. Does what?
Language triangulation. So if there are many examples of Lao into Korean, would it ever go Lao to English?
Okay, so the question is, do we ever use a third language in the translation process? Yes, there are a couple of ways that we do that. Again, I couldn't show every detail in there, but for example, for the Nepali language, we found it has a lot of similarities to Hindi. So in our training, we were able to find models that connected Nepali to Hindi and then used English to Hindi translation to build the English to Nepali translation. Also, for a lot of language pairs, we go through English. So if you try to translate Swahili to Welsh, we don't find a lot of Swahili-Welsh pairs on the web, so we'll go Swahili to English and English to Welsh, and there might be something left at the end. We don't always do that. So on the other hand, if there is a lot of data, there are some pairs like Russian-Ukrainian, Spanish-Catalan, where there actually is a lot, and you can do it directly. Yes.
Have you done any work trying to partially unpack inflected and different word order languages with rules in order to make it canonical and then match them up using your length algorithm?
So the question is, have we done any work to solve the problem of inflection in other languages using rules? The answer is yes, we have. We've done quite a bit, and some of it has even worked. It's very, very hard. It has worked on one language. It has kind of a middling amount of data. When we tried to try the same approach on larger languages, it was promising when we did quick tests on small amount of data, but when we went up to larger amounts of data, it actually got worse. So trying to mix in rules with example-based can work, but it's really tricky, and if you don't do it just right, the rules and the data wind up fighting against each other. Yes?
How do you know which language you're looking at? How does the machine pair that?
Great question. The question is, how do we know which language we're looking at? So one option is the user can tell us, but we do have language detection. That is another whole art in itself. So again, there's a machine learned model of what characters and what character sequences frequently appear in different languages. We also look at dictionaries. So if you pick auto detect in Google Translate and type some text, it applies several algorithms. It looks for, are these exact words we can find in a dictionary for any language, and then says, okay, well, the encoding, is it Latin? Well, we've cut it down. Does it look like Chinese or Japanese? And then we have a machine learned model, and it's fairly accurate, but we're always working to tune it. Yes?
Can you get a grade on how effective the translation was, so that the person says, okay, I can rely on this, or maybe not, maybe just an idea?
So the question is, can we grade how good the translation is and give the user some feedback? That is something we've looked at. We're not doing it right now. There was an earlier question about Google Voice, where the voicemail transcription does something like that. Words that we're confident in are in bold, and words that we're not very confident in are faint. We have tried that, but the quality estimation itself is kind of unreliable, and so far it just looks like it's adding more confusion to try to estimate that. And we can't do something as simple as word by word, because the kinds of errors we can make can be the wrong word or the wrong word order, or maybe we just left out a word. So it's a hard problem. I can see how it could be useful, and we have done some experiments, and I'd like to see something like that happen. But I'd even more like to just make it good all the time. So, yes.
To what extent do you treat languages as sort of monolithically versus taking into account like regional differences or country differences, syntax or word choice?
Great question. How much do we take into account regional differences and variations of like register and so forth in languages? And the answer is we don't directly. So we don't know there are different dialects of some language or a more formal, less formal register. Sometimes, though, we get it surprisingly right, though, because there can be clues in the sentence that point you in the right direction, and you just find the right examples. One of my favorites is going into German. You've got, it's not exactly a regional difference, but the formal, informal, German has Sie and Du, formal and informal. If you type "How are you," with, at least as of recently, with correct capitalization and punctuation, you get it in German in the Sie form, in the formal. If you type it lowercase with no punctuation, you get a Du, you get the informal. Well, it just so happens that we find examples, and so it's sometimes can be surprising what subtle clues can be in a sentence that point you in the right direction. But no, explicitly knowing I want, well, my personal hobby language is Welsh. I'd like to use North Welsh rather than South Welsh. Not there. Okay. Do we have time for one more? Yeah. Okay, one more.
What's the most required translation? What language?
Question is the most requested translation. It's English to Spanish.